Students, we started this lesson, lenses in the last video. Then we studied what is the spherical mirror, types of lenses. That is, there are 6 types of lenses: biconvex lens, plano-convex, then positive, meniscus, biconcave, then plano-concave, and negative meniscus, isn't it? Now, we started this also. We saw the cross section of convex and concave lenses. Okay, what is the cross section? You can see this dark colored part, right? And here also the dark colored part. So that is, this dark colored part, okay, it is a convex lens and this is a concave lens, isn't it? Yes, the middle one. So see, now in this figure, okay, now see in this figure A, okay, you can see there are two spheres, S1 and S2. S1 is the big sphere and S2 is the small sphere. Now, they are intersecting each other, isn't it, at A and B. Now you can see that, see this part which is there, okay, this is the part of the sphere S1, and this part which is there, this is the part of the sphere S2. Now here you can see in this figure, okay, in figure B, okay, this is the sphere S1, that is the smaller sphere, and this is the bigger sphere S2. Now this part which is there, okay, you can see this is the shape of a concave lens. Okay. Now see, the cross section of convex and concave lenses are shown in parts A and B of the figure 7.3. The surface marked as 1 is part of sphere S1, while surface 2 is part of the sphere S2. Now, center of curvature. So, what is the center of curvature? See, the centers of sphere whose parts form surface of the lenses are called centers of curvature of the lenses. So, what is the center of curvature? The centers of spheres, okay? The centers of the spheres whose parts form, you can see here in the figure, okay? Yes. So, the center of curvature, it is denoted by C. Okay. Now, see, what is this center of curvature? The center of the spheres whose parts form surface of the lenses are called centers of the lenses, the center of curvatures of the lenses. A lens with both surfaces spherical has two centers of curvature, C1 and C2. Now see, I'll show you what is the center of curvature in the above figure we will see. See, you can see here, this is the lens, the middle one, AB, isn't it, in this figure A, right? Now, here, when you complete this, okay, this is the part of this sphere, S1 I told you, right? Yes, so when you complete the sphere, you get a center for this. That is the center of curvature C1. Now, the lens has two spherical surface, right? Now, this is one spherical surface, this is the other spherical surface. Now, the center of curvature for this imaginary sphere is C2, right? So, there are two centers of curvatures, right? A lens is having two spherical surface, and that too it is having two centers of curvature C1 and C2. Then radius of curvature. So what is this radius of curvature? The radii R1 and R2 of the spheres whose parts form surfaces of the lens are called the radii of the curvature of the lens. So, because there are two center of curvatures because it is having two spherical surface, right? Now, the radii, okay, the radius of curvature are also 2. So, the radii R1 and R2, two spheres are there. So, there has to be 2 radii, okay. So, the radii R1 and R2 of the spheres whose parts form surfaces of the lenses are called the radii of curvature of the lens. So, let us see in the above figure. See R1, you can see R1 is the radius of the sphere S1, right? And R2 is the radii of the sphere S2. So, there are 2 radii, isn't it? You can see over here R1 and R2. Now, principal axis, the imaginary line passing through both centers of curvature is called the principal axis of the lens. So, what is the principal axis? A line joining. You saw there are 2 center of curvatures, right? Yes, you can see here there are 2 center of curvatures C1 and C2. So, the line which is joining, okay, see, the line which is joining this C1 and C2, that is this line, okay, that is called as the principal axis. Now, optical center, the point inside a lens on the principal axis through which light rays pass without changing their path is called the optical center of a lens. Okay, so what is the optical center? The point inside a lens. Okay, you have seen which is the lens, the middle one of the 2 centers. This was the shape, isn't it? Yes, you can see the dark which is there over here and here, right? So, these 2 are the lens, right? One is the convex lens and other one is the concave lens. So, what is the optical center? The point inside a lens on the principal axis through which light rays pass without changing their path. So, it is a point. Now, you think this, see, this is the lens, isn't it? Now, when light is passing, okay, when light is passing from one medium to the other, the refraction of light is going to take place, isn't it? But see, if the light, okay, passes through the, that is from one medium to other medium, through the optical center, okay, in this lens, that time the light is not going to change its path, isn't it? So, that point we are going to call it as optical center of the lens. Now, see, which is the optical center over here? The point O is the optical center. So, what is the optical center? The point inside a lens on the principal, you have seen this is the principal axis, isn't it? Now, so the point inside this is the lens, right? Now, the point which is there inside the lens, this O, okay? So, the point inside a lens on the principal axis through which, so when light is going to pass through this point O, okay? That time it is not going to change its path. So, the point inside a lens on the principal axis through which light rays pass without changing their path is called the optical center of a lens. So, that is called as the optical center. So, in figure 7.4, rays P1, Q1 and P2, Q2 passing through O are going along a straight line. So, this you can see P1, Q1, okay, and P2 Q2, okay, which is passing through O. See this line P1 Q1, okay, and P2 Q2. So this is passing straight, isn't it? They are passing along a straight line. So O is the optical center of the lens. Principal focus. When light rays parallel to the principal axis are incident on a convex lens, they converge to a point on the principal axis. This point is called the principal focus of the lens. Okay, so what is the principal focus? See, when light ray is passing, okay, yes, when light rays parallel to the principal axis are incident on a convex lens, they are going to converge to a point on the principal axis. Now I will show you. See, okay, see, this is the principal axis, isn't it? Now the rays which are parallel to this principal axis, so these lines, these rays of light are parallel to the principal axis. Now see, the rays of light parallel to the principal axis, when they are incident on this lens, okay, yes, on the convex lens, then what is going to happen? They all, okay, when they pass through this lens, they are all are going to, okay, yes, they are all going to come and converge at a point. So that is called as the principal focus. Yes, so F1 and F2, okay, are the principal foci of the convex lens. Light rays parallel to the principal axis falling on a convex lens come together, that is focused at a point on the principal axis. So this type of lens is called a converging lens. Now you have seen, okay, in the convex lens, what is happening in the convex lens? The light rays which are parallel, okay, see, the light rays which are parallel, you can see over here, yes, they are coming after refraction, okay, they all are converging like this, isn't it? Yes, so what they are coming and converging together, and that is why this type of lens, okay, is called as converging lens. Rays traveling to the principal axis of a concave lens diverge after refraction in such a way that they appear to be coming out as a point on the principal axis. So this point is called the principal focus of the concave lens. F1 and F2 are the principal foci of the concave lens. Now you see, in this concave lens, see, this is the concave lens. Now you can see that the ray of light is parallel, okay, is incident like this. It is parallel to, this is the principal axis, and these rays, okay, they are parallel to the principal axis and they are incident on this concave lens. So what is happening? You feel as though they are coming out like this, isn't it? So that means they are diverging, and that is why this type of lens, concave lens, is called as the diverging lens. Okay, so light rays parallel to the principal axis falling on a concave lens go away from one another after refraction. So this type of lens is called a divergent lens. Students, let us see this practically so you will understand more better the terms, okay, that is used for lenses.
For lenses, what are the general terms? First, consider lenses. Lens is a part of a halosphere. See, this is an halosphere and this is another halosphere, and the interaction part is called the lens. This is a part of a halosphere. The lens is a part of a halosphere. This is called convex lens. This is called convex lens. And the same way, and one halosphere and this is another halosphere, and this part is called concave lens. Concave lens. Next, what are the important terms related to them? So first one is center of curvature. What is the center of curvature? The center of the sphere. See, this is what is the center of curvature? The center of the sphere, halosphere. This is the center of the halosphere, and so the center of the imaginary glass halosphere of which the lens is a part. Okay, this lens is a part of this halosphere. Therefore, the center of the halosphere becomes the center of curvature of the lens, convex lens. So here also, this is the center of curvature of the convex lens. So here this is C1 and C2 or the center of curvature of the halosphere. Same way in this case concave lens have the center of curvature C1 and C2. Here these two are the centers of this halosphere. Okay, now so what is the center of curvature? Here the C1 and C2 are the center of curvatures. These two are the center of curvatures. Next, what is another important? The principal axis. The imaginary line passing through the center of the curvature of the lenses is called principal axis. Here this is the principal axis. This is a principal axis. Principal axis. This is passes through the center of the curvature of the lens. Here also, in case of convex lens, also this is the principal axis. This passes through the center of the curvature of the lenses. This is principal axis. Okay. Next, what is another important term? This is aperture. Aperture of the lens. What is the aperture? The diameter of the lens. The diameter of the lens through which the refraction takes place. Suppose this is the diameter of the lens, and here also this is the diameter of this convex lens, and this is diameter of the concave lens. This is called aperture of the lens. This is called aperture. This line is called aperture. This is called aperture. Here also it is aperture. Okay. So this is the diameter of the convex lens and this is the diameter of the concave lens. This is called aperture. Next, what is another important term? That is optical center. The another important term is optical center. What is optical center? It is a point within the lens. This is a point within the lens. A point within the lens where the diameter of the lens, that means the aperture of the lens and principal axis meets, is called optical center of the lens. This point O is called optical center. Here it is O is called optical center. Okay, in these two cases O is called optical center. Here the aperture and principal axis are met at this point. This is called optical center. Next, principal focus. What is principal focus? It is a point on principal axis. This is a point on principal axis for convex lens where the parallel beam of light, if a parallel beam of light strikes the convex lens, after refraction they are met at this point. This point is called principal focus. This is F1, F2. So these are the principal focus. What is principal focus? Where the parallel beam of light after refraction meets, that point is called principal focus. So this is the principal focus of convex lens. At the same time, in case of concave lens, When a parallel beam of light strikes the concave lens, after refraction, the rays are diverges. That means it appears to diverging from a single point. This point is called principal focus. Next, what is another important term? Focal length. Focal length means the distance between the optical center and principal focus is called focal length. The distance between optical center and principal focus is called focal length. This is called focal length. And here it is called focal length. Okay, this is called focal length. So here f is the focal, the distance f is the focal length. F is the focal length. Next, here it is xy. xy is principal axis. xy is principal axis. And f1 and f2 are focus. For focuses of different types of lenses, convex lens and concave lens. Okay, these are the importance related to lenses. Okay, thank you.
Now focal length, the distance between the optical center and principal focus of a lens is called its focal length. Okay, so you know what is the focal length. So what is this focal length? The distance between the optical center, okay, and principal focus, that is going to be the focal length. So I have shown you in the just now a small video clip regarding this, isn't it? So you can see optical center O, isn't it? So from there to the principal focus, that is F1 and F2. Okay, so that is going to be the focal length from O to F1 or from O to F2. That is going to be the focal length. So I'm sure you must have understood this general terms, okay, which are used regarding the concave lens and concave lens, that is convex lens, that is center of curvature, radius of curvature, principal axis, optical center, principal focus and focal length. So let us continue, okay, with this, that is the activity. Try this in the that is in the next video. Okay, so the material required for this is convex lens, screen, meter scale, stand for the lens, etc. So let us continue that. Okay.